Thanks to $30 million in funding provided through the American Recovery and Reinvestment Act, the U.S. Department of Energy and Brookhaven National Laboratory were able to accelerate a unique reactor decommissioning project on the Brookhaven lab site. The project involved removing 700 tons of radioactive graphite from the center of the Brookhaven Graphite Research Reactor, a historic facility that operated from 1950 to 1968. The reactor was the world's first designed strictly for peaceful research purposes. It produced vast numbers of neutrons that researchers used to study the atomic structure of different materials, leading to advances in physics, material science, and medicine. At the reactor's heart is a cube of graphite, 25 feet on a side, made up of more than 60,000 individual graphite blocks. This provided an engineering challenge for the decommissioning team, which removed the radioactive graphite using a remote-controlled excavator and crane equipped with robotic intelligence. George Schnars explains.
My name is George. I'm George Schnars. I'm one of the two shift operations managers that are involved with removal of the graphite from the old Brookhaven Graphite Research Reactor. Last year, about this time in April, the two crews were assembled to begin removal of the graphite. This is the primary source of radioactivity that's left in this facility, and we're taking it out and shipping it out west for long-term burial. The graphite is composed of roughly 60,000 blocks of 4x4 slabs, each one of varying lengths. There's 75 layers here, composed of roughly 700 tons of graphite. We are currently down to just about down to this level here, level 5. 9 and 5 is what we're mining right now. We operate the system through cameras. We have a control trailer inside the building, and there's an array of video displays in front of the operator, and he can select any which display he wants depending on what area he's working in and where he can get the best viewing. That was another issue that the engineer was able to solve for us, where he provided additional cameras that literally hang down into the pile opening. There's one on each side, and it's on a set of tracks, so we can move it back and forth depending on where we're doing our digging. And we can also add poles to extend it further down. As we remove more and more graphite, we can go further down so that we can see right where the bucket is making contact with the graphite, because it's important to see that point of contact that allows us to continue to dig. And we're literally stripping off one layer at a time, 1 or 2 layers at a time. Graphite dust is not really flying around. It tends to settle out. It's granular. It's more like a bag of sugar than a bag of flour. But we have this fixative that we make, and we spray it around liberally to keep any dust that does come about in place. You know, when we get done, when the night shift gets done at the end of the day, they spray everything down to make sure that there's nothing loose that could fly around. Just additional precautions that we take to make sure we limit spread of contamination. There's a multitude of graphite reactors. A little bit different design, but graphite reactors nonetheless. Same thing, piles, where they're constructed the same manner. And we've had several tours from Hanford out in Washington State, another tour of people from Tennessee with the X-10, which was the predecessor to this reactor. They're going to be removing the graphite there. So those people have been here to find out what the lessons are that they can benefit from our experiences. And I know one of our, Dr. Fred, one of our staff people, is headlining the Lessons Learned project to try and capture all this information to be beneficial to these other groups. What we're going to do is, right now we're removing the graphite, which is the guts of the reactor, and the next phase we're going to be taking out the rest of the structure, the steel and the concrete that shielded the people from the radiation that was internal to the reactor. That's all going to be removed and sent out to a burial site. And I think that's a good thing, because you know, it's put it to a place that's safer, away from people, away from society, where we don't have to worry about any contamination to the environment and my future generations.
The Recovery Act provides enough funding to complete the final stages of the project: removing the graphite pile, dismantling the concrete and steel shield that surrounds it, and placing an impermeable barrier around the building. The entire project is scheduled to be completed in 2011.